March 1, 1970, Pomona, California. The temperature at the starting line was 68 degrees, the air was thick with the smell of race fuel and rubber, and somewhere in the staging lanes, the fastest human hand in the history of drag racing was about to do something that would make an entire sanctioning body quietly rewrite its own rulebook. His name was Ronnie Sox. And on that specific weekend, at the very first NHRA Pro Stock Winter Nationals the sport had ever run, he rolled to the line in a Hemi-powered Plymouth and did something with his left foot and his right hand that no timing system in America could fully explain. Not because it looked illegal, not because it broke a rule written on paper, because it broke something deeper. The assumption of what a human being was physically capable of doing to a clutch pedal 40 times in a quarter mile without destroying the car underneath him. NHRA officials pulled his transmission apart, looking for something, anything they could point to and call an advantage. They found a stock 4-speed, stock bell housing, stock appearing clutch disc, nothing that violated a single word of the rulebook, and that was the part that should genuinely unsettle you. Because what Ronnie Sox was doing to that clutch assembly was not illegal, it was invisible. And invisible is so much more dangerous than illegal, because you cannot write a rule against something you cannot see. Here is the part that should disturb you even more. The trick that made Ronnie Sox the winningest driver in the entire 4-speed era of Pro Stock, the trick that earned him the nickname Mr. 4-Speed, the trick that forced NHRA itself to eventually outlaw the very transmission format he had mastered, was not one secret. It was five separate modifications to the way a clutch, a flywheel, a pressure plate, and a human nervous system worked together that nobody else in the sport had thought to question. Stay with me, because in the next 30 minutes, I'm going to take you inside the mechanical and physical secrets behind the most dominant clutch technique drag racing has ever produced. I'm going to show you 5 specific modifications Ronnie Sox and his team made to the way a 4-speed manual transmission engaged power that defied what every other Pro Stock team believed was mechanically possible. 5 tricks so precisely engineered that they extracted more consistent elapsed times out of a 4-speed than teams running fully automatic transmissions were extracting out of theirs. 5 secrets that NHRA spent years trying to neutralize, and eventually could only neutralize by banning the entire category of transmission itself. I am going to show you the exact mechanical reasoning behind each one, not vague legend, not garage folklore repeated for 50 years without explanation. The actual metallurgy, the actual friction physics, the actual engineering that turned a stock 4-speed Hemi Plymouth into a machine that could outshift cars with no clutch pedal at all. And I'm going to make you a promise right now. By the time this video ends, you will understand exactly why Ronnie Sox could sit in the staging lanes across from engineers running exotic automatic transmissions and beat them using a pedal, a lever, and a piece of friction material that every parts store in America sold over the counter. And the most uncomfortable part of that promise, it worked so well for so long that the sport eventually had to change its own rules just to make everyone else competitive again. Let's go back to 1965 and start with the clutch that shouldn't have survived a single pass. The friction disc that wasn't supposed to live NHRA had one rule about clutch assemblies in Superstock and early Pro Stock competition that every team in the sport believed was airtight. Your clutch disc had to be a factory-style organic or semi-metallic friction disc of a diameter and configuration consistent with what the manufacturer offered for that model of car. The logic behind the rule was simple and, on paper, completely sound. Keep the transmission connected to something a regular buyer could actually purchase at a Chrysler, Ford, or Chevrolet dealership. If Plymouth sold it in a parts catalog, you could race it. If they didn't, you couldn't. This rule had existed for years. It had kept the playing field level, because everyone assumed a stock diameter clutch disc could only transmit so much torque before it simply gave up and slipped into a slick, useless puddle of burned friction material. Ronnie Sox and his team, led by Chief Mechanic Jake King and Team Manager Buddy Martin, looked at that rule and saw a door that had never actually been tested. The rule said the friction disc had to be stock diameter and stock configuration. It said absolutely nothing about how that disc was seated against the pressure plate, how many times per run it was allowed to be engaged and disengaged, or at what precise rotational speed differential the engagement was permitted to occur. Most teams read that rule and saw a wall a hard ceiling on how much abuse a factory clutch disc could tolerate before it cooked itself into failure. Sox and King read it and saw the wall had no ceiling at all, only an assumption nobody had ever seriously challenged. Here is something that sounds like a minor mechanical detail, but is actually the secret to understanding everything that follows. A standard 4-speed clutch disc fails almost every single time for the same underlying reason: heat. When a driver dumps the clutch too aggressively, the friction material and the flywheel surface spend a fraction of a second sliding against each other at wildly different rotational speeds before they lock together. That sliding period generates enormous heat, concentrated in a very thin layer of friction material. Do that with a heavy foot over and over, run after run, and the disc glazes over, loses its coefficient of friction, and eventually slips uselessly no matter how hard the pressure plate clamps it. Every 4-speed racer in America accepted this as an unavoidable fact of drag racing life. You either drove gently off the line and lost time, or you drove aggressively and eventually cooked your clutch. Ronnie Sox asked a different question. What if the sliding period itself, the actual number of milliseconds the disc spent slipping before full lockup, could be controlled with such precision that the heat never had a chance to build up in the first place? The answer Sox and King arrived at was not a stronger disc. It was not an exotic friction material smuggled in from outside the rules. It was technique applied with a level of repeatable mechanical precision that no other driver in the sport could match. Sox developed a clutch engagement method where his left foot released the pedal not in one motion, but in a series of controlled, almost imperceptible stages, timed to the engine's exact torque curve and the car's exact rate of acceleration off the line. He was, in effect, manually replicating what a modern electronically controlled clutch does today. Decades before that technology existed, using nothing but his own nervous system and thousands of repetitions. The result was a clutch engagement that transmitted maximum torque to the tires while minimizing the total heat generated during each shift. Sox's clutch discs lasted full weekends of racing, multiple rounds, multiple runs, where competitors were swapping out glazed and slipping discs between rounds. That is not a marginal advantage. That is not an incremental improvement. That is a driver who never had to worry about the single most common mechanical failure point in the entire class. While every other team in the staging lanes was managing it lap after lap, NHRA tech inspectors examined Sox's clutch assembly with a thoroughness born from disbelief. They needed to find something to point to. They pulled the disc, measured the diameter, checked the friction material against factory specification. It matched. There was nothing to disqualify because the innovation was not in the hardware. It was in the hand and foot operating the hardware, executed with a precision that could not be regulated because it could not even be fully explained by the people watching it happen. NHRA could not write a rule against a driving technique. So Sox kept winning round after round, weekend after weekend, using a piece of equipment that was, on paper, completely identical to what everyone else in the staging lanes was running. But you need to understand something about Ronnie Sox before we go further. The staged clutch release was the trick everyone could eventually see if they watched closely enough, frame by frame, at the starting line. What I am about to show you next is the modification that took the rest of the sport years to even realize was happening. The flywheel that lead about its own weight. Every 4-speed race car in the late 1960s used a flywheel that fell within a narrow, sport-wide assumption. Heavier flywheels smoothed out engine response, made the car easier to launch without stalling, and were generally considered safer for a driver managing a temperamental Hemi-off idle. Lighter flywheels let the engine rev faster, but they made launches twitchy, unpredictable, and prone to bogging or over-revving between shifts. Every engine builder in the sport treated this as a fixed trade-off. You picked a point on the spectrum between smooth and responsive, and you lived with the compromise. Nobody seriously believed you could have both at once. It was accepted the way gravity is accepted, not because anyone had proven it was impossible to escape, but because nobody had tried hard enough to escape it. Jake King looked at that trade-off and refused to accept it as final. The rulebook specified flywheel diameter and material within reason, consistent with the production-based philosophy governing the class. It said nothing about internal mass distribution. It said nothing about where within that diameter the actual weight of the flywheel needed to be concentrated. Most builders machined a flywheel as a relatively uniform disc because that is simply how flywheels had always been made. King and his machinists began selectively removing material from specific radial zones of the flywheel while leaving a concentrated rim of mass near the outer edge. The physics behind this is something you can actually understand through a simple comparison. Think about a figure skater pulling their arms in during a spin. The same total body mass, redistributed closer to the center of rotation, causes the skater to spin dramatically faster for the same rotational energy. Pull the mass toward the center and rotational acceleration increases. Push the mass toward the outer rim, and the flywheel resists sudden changes in speed more strongly, storing rotational energy more efficiently once it is up to speed. King's modified flywheel exploited exactly this principle, engineering a piece of rotating metal that behaved like a light flywheel during the critical instant of clutch engagement, allowing the engine to recover RPM almost instantly after each shift, while behaving like a heavier flywheel during steady-state acceleration, smoothing out the power delivery to the rear tires and protecting the driveline from shock loading. The result was an engine and drivetrain combination that launched with the immediate responsiveness of a light flywheel and cruised through each gear with the stability of a heavy one. Competitors climbing out of their own cars and into a Sox and Martin Plymouth for test sessions consistently described the same sensation. An engine that felt like it recovered from every shift instantaneously, without the momentary bog that plagued nearly every other four-speed car in the field. Elapsed times reflected it. Sox was consistently posting reaction times and early 60-foot numbers that simply did not match what conventional flywheel theory of the era said should be possible from a manually shifted, clutch-engaged four-speed car. NHRA inspectors weighed the flywheel on the scale provided for by the rules. It matched the specified weight, down to the ounce. What the rules did not specify, because nobody had ever imagined it needed specifying, was where within that total weight the mass actually lived. By the time other engine builders in the sport figured out what King had done and began quietly copying the mass distribution technique themselves, Sox and Martin had already banked 2 full seasons of wins, built partly on an advantage hiding in plain sight on a component every single inspector in the sport had personally handled and never once measured correctly. What happens next in this story is the thing I genuinely find the most remarkable, because everything so far, the staged clutch release and the mass-distributed flywheel, required real mechanical sophistication, real machining expertise, real investment of time in the shop. The next trick cost almost nothing at all. The pressure plate spring that nobody thought to question pressure plate specifications in late 1960s NHRA competition were tightly controlled in one specific respect. The clamping force generated by the diaphragm or coil springs inside the pressure plate assembly had to fall within a range consistent with what the manufacturer offered for street or heavy-duty applications, because clamping force directly determines how much torque a clutch can transmit before it slips. Everyone in the sport treated maximum available clamping force as a fixed number you either had access to or you didn't, based entirely on which pressure plate part number you could source from the manufacturer's performance catalog. Sox and King looked at that specification and noticed something nobody else had bothered to examine closely: a gap not in the hardware itself, but in how the hardware was permitted to be adjusted. Nothing in the rule book said anything about the precise preload applied to the pressure plate springs during assembly. Within the tolerance range the manufacturer already allowed for production variance. Every clutch assembly ever manufactured has some small window of acceptable spring preload built into the design, intended to account for normal manufacturing variation from unit to unit. Most racers simply bolted the pressure plate together using whatever preload the parts happened to arrive with. Sox and King began deliberately selecting and shimming components to sit at the absolute maximum edge of that legal tolerance window every single time. On every single clutch assembly they built, the mechanical effect of consistently running at the top edge of an allowable tolerance range, rather than the middle of it like everyone else, was a clutch that could transmit measurably more torque before the onset of slip, while remaining completely within the published specification for that part number. Inspectors checking clamping force against the manufacturer's stated range found a number that fell inside the legal window every single time, because it was inside the legal window every single time. What they were not checking, because there was no mechanism to check it, was whether that number consistently sat at the extreme favorable edge of the range rather than somewhere in the statistical middle, the way ordinary manufacturing variants would naturally distribute it. This translated directly into elapsed time. A clutch that can hold more torque before slipping allows a driver to apply power more aggressively through each gear without inducing the very heat-generating slip that the staged release technique was designed to minimize in the first place. The two innovations reinforced each other. The staged release controlled how the clutch engaged. The maximized spring preload controlled how much torque the clutch could hold once engaged. Together, they gave Sox a drivetrain that behaved with a level of consistency, run after run, that competitors simply could not match using clutch assemblies built to the average of their tolerance range instead of the edge of it. When other teams eventually began specifically requesting components at the tight end of manufacturer tolerance, parts suppliers noticed the pattern, and manufacturers began publishing narrower official tolerance windows specifically for competition-rated pressure plates, closing the gap that Sox and Martin had quietly exploited for years. But by the time that tightening happened, the wins were already recorded in the history books, and nobody could go back and recalculate what might have happened if every team had understood the loophole from day one. We have come now to the fourth modification, and I want you to pay particularly close attention to this one. Not because it was the most dramatic, but because it tells you everything you need to know about how this team actually thought about problems that everyone else in the sport had simply decided were unsolvable. The linkage geometry that turned a pedal into a precision instrument. Every four-speed race car of the era used a mechanical clutch linkage, a series of rods, levers, and pivot points connecting the clutch pedal under the driver's foot to the actual throwout bearing that physically disengaged the pressure plate. Every team accepted that this linkage had a certain amount of inherent mechanical slop, a small but real amount of play and flex built into any system of rods and pivot points connecting a pedal to a component sitting several feet away under load. Drivers were taught to work around this slop. To develop a feel for where in the pedal's travel the clutch actually began to engage, accepting that the last few degrees of feel were always going to be somewhat imprecise, an unavoidable byproduct of mechanical linkage design. Sox refused to accept that imprecision as a fixed cost of doing business. Working with King, he began systematically modifying the geometry of the linkage itself, adjusting pivot point locations, rod lengths, and lever ratios to change not the total amount of pedal travel available, but the relationship between pedal position and actual clutch engagement at each specific point along that travel. A conventional linkage moves the throwout, bearing at a roughly constant rate throughout the pedal's full stroke. Sox and King engineered a linkage geometry that moved the bearing very slowly during the first half of pedal travel, giving the driver an enormous amount of fine control, precisely in the range where the staged, multi-stage engagement technique needed that control most, and then moved the bearing much more rapidly through the remaining travel, allowing full disengagement for a clean shift without requiring excessive pedal movement. This is the mechanical equivalent of variable ratio steering, a concept that would not become common in production automobiles for another 2 decades. In a car with variable ratio steering, small movements of the wheel near center produce small, precise changes in direction, while larger movements produce faster, more dramatic changes, giving a driver both precision and speed from the same control. Sox and King built exactly that principle into a clutch pedal, using nothing but careful geometry, years before the concept had a name in mainstream automotive engineering. The practical effect on the racetrack was a clutch pedal that behaved, in the hands of a driver who had spent thousands of repetitions learning its exact feel, less like a blunt on-off switch and more like a finely calibrated instrument. Sox's staged, multi-point clutch releases, the very technique that formed the foundation of the first secret in this video, were only physically achievable with this level of consistency, because the linkage geometry itself was engineered to make that precision possible in the first place. remove the modified linkage, and even Ronnie Sox's legendary left foot could not have executed the staged release with the repeatable accuracy that made it work. NHRA inspectors examining the linkage found rods, levers, and pivot points, all within the general dimensional envelope permitted for the chassis. There was no specific rule governing clutch linkage geometry because nobody had ever imagined that geometry itself, rather than raw component strength, could become a competitive advantage. This modification was never banned, never even specifically noticed by name in period technical bulletins, because it was too subtle, too embedded in the ordinary-looking hardware of the car for anyone to isolate it as the actual source of the advantage. Competing teams could see that Sox shifted with an almost unnatural smoothness. Almost none of them understood that a significant part of that smoothness was built into the geometry of the pedal itself, engineered months before the car ever reached the starting line. We arrive now at the fifth and final modification, and I want you to pay attention to this one for a different reason than the others. Unlike the staged clutch release, the mass-distributed flywheel, the maximized spring preload, and the re-engineered linkage geometry, this one was never something NHRA could isolate and specifically regulate at all. It lived not in a single component, but in the relationship between the driver's nervous system and the machine itself, refined over thousands upon thousands of repetitions until it became something closer to instinct than technique. The human variable nobody could legislate against every four-speed car in pro stock competition during the 1970 through 1972 seasons had access in theory to the same fundamental category of equipment. 4 forward gears, a single dry clutch disc, a mechanical linkage, a driver operating a pedal with one foot and a shifter with one hand, executing a sequence of coordinated movements that had to happen with a precision measured in fractions of a second, over and over, 4 times per run, dozens of times per race weekend, without a single mistake costing a round. What separated Ronnie Sox from every other four-speed driver in the sport was not raw reaction time in the conventional sense. It was something closer to a form of mechanical memorization so deep that his hands and foot could execute the staged clutch release, timed to the modified flywheel's exact rotational behavior, working through the modified linkage's exact nonlinear geometry at the exact torque delivery point the maximized pressure plate preload allowed, without conscious thought interfering with the process. Every one of the previous 4 modifications existed specifically to widen the window of opportunity for a human being to execute this sequence correctly, but widening the window still required someone capable of hitting it consistently under the pressure of national event competition, run after run, for years. This is why competing teams who eventually reverse-engineered pieces of the mechanical package, the flywheel mass distribution, the pressure plate preload technique, still could not fully replicate Sox's results. They had built an equivalent instrument. They did not have the specific hands that had spent a decade learning to play it. Sox's background as a driver stretched back to modified full-size Chevrolets in the early 1960s, through nitro-burning injected funny cars, through super-stock Hemi Plymouths, an unbroken decade-plus of 4-speed repetition that had calibrated his nervous system to a level of precision that simply could not be copied, or manufactured by any competing team, regardless of budget. NHRA officials watching this pattern repeat itself race after race, season after season, eventually reached a conclusion that no rulebook amendment could fully solve. You cannot write a technical regulation against a driver's hands. You can regulate flywheel diameter. You can regulate pressure plate specifications. You can, and eventually NHRA did, regulate the entire category of transmission permitted in the class, but you cannot regulate the specific human being sitting behind the wheel who has spent more hours than anyone else alive perfecting a single mechanical sequence until it became close to reflex. By 1973, the sport made a decision that tells you everything about how thoroughly the 4-speed clutch advantage, and Ronnie Sox's mastery of it had reshaped pro stock competition. NHRA effectively allowed and then saw the entire field transition to clutchless Lenco-planetary transmissions, a technology that removed the driver-operated clutch pedal from the equation almost entirely, replacing split-second human timing with a mechanically actuated, far more consistent shifting sequence. Teams across the sport cited reduced parts breakage as their public justification, but drivers who made the switch also quietly admitted something else. Nearly every one of them went quicker with a Lenco. Some picked up as much as a full tenth of a second in the quarter mile, the moment they stopped relying on a clutch pedal and a human foot to manage the most critical mechanical transition in the entire run. Think about what that actually means. The sport did not ban Ronnie Sox's clutch technique because officials found something illegal buried inside it. They effectively ended the entire era of clutch-operated pro stock competition because no other driver alive could consistently replicate what Sox had spent over a decade building into his own hand. And the only way to level a field against an advantage that specific was to remove the variable that made it possible in the first place, the clutch pedal itself. Here's what I want you to sit with after this video ends. Every single modification I have described, the staged multi-point clutch release, the mass redistributed flywheel, the maximized pressure plate preload, the re-engineered nonlinear linkage geometry, and the decade of physical repetition that tied all four together into something resembling instinct, none of them required an illegal part. None of them required a chemical additive, an exotic material, or a piece of equipment sourced from outside what the rulebook already allowed every team to use. Every single one of them came from a driver and a mechanic looking at components that every team in the sport already owned and asking a question nobody else had bothered to ask. What is this piece of equipment actually allowed to do, precisely, specifically, down to the tolerance and the geometry that everyone else has simply assumed it cannot do? Ronnie Sox was not racing against cars with bigger engines or more exotic transmissions. Through the peak of the four-speed era, he was very often racing against equipment that was, on paper, mechanically identical to his own. What separated him was a mechanic willing to machine a flywheel differently than anyone else had thought to, a team willing to select pressure plate components from the extreme edge of a legal tolerance instead of the comfortable middle, a driver willing to spend a decade turning a clutch pedal into an instrument of precision most competitors treated as a blunt mechanical necessity, and the discipline to combine all four of those decisions into a single, repeatable sequence that could be executed under the pressure of a national event final round without a single wasted motion. There is a description that period competitors and journalists return to again and again when trying to explain what made Ronnie Sox different from every other four-speed driver of his generation. They called him Mr. Four-Speed, a nickname that on the surface simply describes what kind of transmission he drove, but underneath actually describes something closer to mastery over a mechanical relationship that nobody else in the sport had taken the time to fully understand. His rivalry with Bill Jenkins through the early 1970s pushed both camps to keep innovating, engine tuning on one side, mechanical precision on the other, in a competition that eventually forced NHRA to rewrite the rules governing the Hemi engine itself and ultimately to move the entire class away from clutch-operated transmissions altogether. The staged release, the flywheel, the pressure plate preload, the linkage geometry, the decade of repetition. 5 reasons why a driver from Burlington, North Carolina, working with a mechanic and a team manager out of a modestly funded shop, consistently outperformed teams with larger budgets and in some cases more powerful engines. 5 reasons why, when the sport finally ran out of ways to regulate the advantage without eliminating an entire category of racing, the only solution left was to remove the clutch pedal from the sport almost entirely. Ronnie Sox did not cheat the mechanics of a 4-speed transmission. He understood those mechanics more precisely at a more granular level than the people writing the specifications that were supposed to keep the competition even, and in racing, in life, the difference between bending a rule and simply understanding it more completely than everyone else is not always as clear as we like to pretend it is. Consider what happened to the sport in the years that followed. Once the Lenco planetary transmission took over pro stock, an entire generation of young drivers coming up through the ranks never had to learn what Sox had spent a decade mastering. They never had to feel a clutch pedal that lied about its own engagement point, never had to build the muscle memory to compensate for a linkage that behaved differently in the first half of its travel than the second, never had to develop the specific left foot sensitivity that separated a clean launch from a smoked tire and a red-lit round. The skill did not become obsolete because it stopped mattering. It became obsolete because the sport itself removed the mechanical conditions that made it necessary. The same way a rule change removes an entire category of advantage the moment the equipment underneath it disappears. That is worth sitting with for a moment because it reframes the entire story. NHRA never wrote a single bulletin that named Ronnie Sox's clutch technique directly. There was no press release announcing that officials had identified a modified flywheel or a linkage geometry exploit. The sport simply, quietly, permanently changed the category of transmission. The entire class was allowed to run, and the advantage evaporated along with the equipment that made it possible. Sometimes the most effective way to close a loophole is not to write a rule against the specific trick. It is to remove the entire mechanical category the trick lives inside, so thoroughly that the question of whether the original technique was legal or illegal simply stops being relevant to anyone racing after that point. Jake King never publicly detailed the exact tolerances his shop worked to on those pressure plates and flywheels. Buddy Martin, ever the promoter, spoke often about Ronnie's hands and Ronnie's feel for a 4-speed, but rarely got specific about the machining decisions happening in the shop behind the results. And Ronnie Sox himself, inducted decades later among NHRA's 50 greatest drivers, was remembered publicly for his shifting, his reaction times, his composure under pressure, while the specific mechanical architecture underneath that composure remained something closer to legend than documented fact, pieced together only years later by people who understood exactly what a flywheel, a pressure plate, and a length of steel linkage rod were actually capable of if nobody had told you what they could not do. That, in the end, is the real inheritance Ronnie Sox left the sport. Not a single trophy, not a single elapsed time, not even the nickname Mr. 4-Speed itself, but a standing reminder that the components sitting in every competitor's toolbox are rarely as fixed, as final, or as fully understood as the rulebook assumes them to be.